Okay, our topic is determining redox reaction, whether the reaction is redox or not. If there is a change in oxidation number, the reaction is redox. If there is no change in oxidation number, the reaction is not redox. Oxidation is the loss of electrons that results in the oxidation number becoming more positive or less negative. Example, positive 2 to positive 3, or less negative, negative 2 to 0. Reduction means there is a gain of electron that results in the oxidation number becoming more negative or less positive. Example, 0 to negative 3. This is becoming more negative or less positive, from positive 4 to positive 2. Okay, so here is an example. If there is a change in oxidation number, we can determine if it is redox. So we can see here that the magnesium has an oxidation number of 0, and then it changes to become positive 2 with the oxidation number of positive 2. Also, oxygen in the reactant side from 0 to negative 2. Okay, so the reactants on the left side, magnesium and oxygen, has or have changes in their oxidation number. Therefore, this is a redox reaction. By and by, we will also determine whether the reaction is by and by we will determine if in the reactant side what is the reducing agent and the oxidizing agent pagkatapos nito. Another example in determining whether the reaction is redox or not, Fe2O3 plus CO will yield Fe plus CO2. So we can say here that this is also a redox reaction. Why? Because there are changes in oxidation number. Remember, if there are changes in oxidation number, it is a redox reaction. And Fe2O3, in the reactant side, positive 3 in Fe2 and iron becomes 0. The oxidation number becomes 0 from positive 3 to 0. Okay. Here, the oxygen is also the same. The carbon in the reactant side, positive 2 to positive 4. Okay, so we will apply the rules by and by. So here are the rules. We will return to the rules. I have not explained this in the first example. So the rules here are the following. It becomes an oxidation here, oxidation when there is a loss of electron and it results in the oxidation number becoming more positive or less negative. So you see here, oxidation becoming more positive from positive 2 to positive 4. It is becoming more positive. That's why it is called oxidation. You see here, oxidation. Now it is a reduction when the electrons becoming more negative or less positive. So reduction, the Fe to Fe, because from less positive, the oxidation number becomes less positive. Okay, so that's the rules that we have applied. And the last, this is not a redox reaction. Why? As you can see, hydrogen here is positive 1 and the product side is positive 1. There are no changes. Sodium is positive 1 and the product side positive 1. No change in oxidation number. No change in oxidation number. Therefore, this is not redox. Okay? So this is how simple in determining whether the reaction is redox or not. Okay, we will go to another topic, which is identifying which in the reactant side is oxidizing agent and the reducing agent. Identifying the reducing and oxidizing agents in the reactant. Here are the tips, or the tip, or the mnemonic device. we have the LIORA and GIROA acronym. LIORA means L stands for losing, E electron, O oxidation. So we cannot determine if it is oxidation, the element will be the reducing agent, or the reactant, or the compound in the reactant will be the reducing agent. If the element gains electron, it is called reduction. So gaining electron is reduction. This will be now our oxidizing agent in the reactant side. Remember, the elements in the reactant side, or the oxidizing agent and the reducing agent, will never be the product side, will never be seen in the product side. Okay, so hinahanap lang natin ang mga oxidizing agent, ito, at reducing agent, sila ay makikita lang sa reactant side. Okay, let's have an example. Okay, so bear in mind again that losing electron is oxidation. So you see oxidation, this one has lost its electron. So from 0 to positive 2 magnesium. So losing electron is oxidation. LIORA, this will be now our reducing agent. Okay, so you see here, reducing agent. Magnesium is the LIORA, or the reducing agent. Oxygen gained electrons from 0 oxidation number to negative 2. So therefore this is our GIROA, or gained electrons is called the reduction. So you see here the reduction. So oxygen is our oxidizing agent. And of course this is a redox reaction. Okay, so example number 2. Okay, so this is quite different. Fe2 positive 3, and dito sa product side ay 0. So siya ngayon naman ang ating oxidizing agent. Why? Because siya yung nag-gain ng electron from positive 3 to 0. Okay, so do not be confused with our rules kanina. So this our reduction is GIROA. Gained electron is reduction or reduced. Therefore, iron is our oxidizing agent in the reactant side here. The reducing agent should be the oxidation, or the one that is oxidized. So from positive 2, we have the carbon and another carbon in the product side. It becomes positive 4. So it becomes more positive from positive 2 to positive 4. So it is called oxidation. Katulad ng sinabi ko kanina sa non-example. Therefore, the carbon monoxide in the reactant side is our reducing agent. Okay, so this is a redox reaction. So, LIORA siya, losing electron is oxidized. Okay, from positive 2 to positive 4. So, our oxidizing agent is iron, or the Fe2O3, while our reducing agent, or the Ra, is the carbon monoxide. Okay? Okay, this one, we will have no oxidizing agent and reducing agent because there is no reaction. This is not a redox reaction. Okay? So we have exam time. Determine if the reaction is redox or not. You may pause this for a while. Okay? After computing. So another question, number 2. What is the reducing agent or oxidizing agent in the reaction below? You may also pause. Pwede kayo mag-pause para mag-solve. Okay, and here is our answer. Okay. So, this is now the end of our topic, determining whether the reaction is redox or not, and identifying the oxidizing and the reducing agent. You may play again the video so you can learn more. Thank you.